Article 400 of the National Electrical Code addresses flexible cords and cables. However, it's crucial to understand the scope of this article. The opening sentence of 400.1, Scope, clarifies its applicability. This article applies to installations of conductors and equipment within or on public or private buildings, structures, mobile homes, recreational vehicles, and floating buildings. Installations in ships, watercraft other than recreational vessels, railway rolling stock, and aircraft are not covered by this article. Therefore, if wiring is integral to a piece of equipment, Article 400 typically does not govern its installation. An example would be the wiring inside an overhead door motor assembly. The wiring from the motor to the control panel within the equipment is considered part of the equipment itself. This means the local inspector's citation of 400.7-10 in this case is likely not applicable. However, it is essential to always consult the latest version of the NEC and any local amendments. The manufacturer's recommendations play a vital role in such installations. Even if Article 400 doesn't apply, adhering to the manufacturer's specifications for shielded cable is important for proper equipment operation and electromagnetic compatibility. The manufacturer's documentation takes precedence regarding the type of cable to be used. Regarding the use of conduit, if the manufacturer does not specify conduit and no other article in the NEC requires it for that specific application and location, then it might not be necessary. However, always consider physical protection requirements based on the environment where the equipment is installed. If the wiring is exposed to potential damage, conduit might be a prudent choice, regardless of whether it's explicitly mandated. In this situation, the low-voltage multi-conductor cables for control should also be considered integral to the equipment if they are part of the overhead door system. If they are, Article 400 likely would not apply to them either. Again, follow the manufacturer's recommendations for these cables and consider the need for physical protection based on the installation environment. The inspector's rejection based solely on Article 400 is contestable if the wiring is indeed integral to the equipment. It is always a good practice to have open communication with the electrical inspector. Providing the manufacturer's documentation and a clear explanation of why you believe Article 400 does not apply can help resolve the issue. If a disagreement persists, seeking clarification from a higher authority within the inspection department or consulting with a qualified electrical engineer might be necessary. Regarding the use of shielded cable, it's important to understand why the manufacturer recommends it. Shielded cable helps to minimize electromagnetic interference, which can be crucial for sensitive electronic equipment. The shield provides a barrier that prevents external electromagnetic fields from interfering with the signals carried by the conductors within the cable. It also helps to contain electromagnetic radiation generated by the conductors, preventing it from interfering with other equipment. Grounding the shield properly is essential for it to function effectively. Typically, the shield is grounded at one end only to prevent ground loops, which can introduce noise into the system. The manufacturer's instructions should specify the proper grounding method for the shielded cable. The recommendation to use shielded cable likely arises from considerations related to electromagnetic compatibility, or EMC. Modern electronic equipment can be susceptible to interference from various sources, and shielded cable is one way to mitigate this risk. EMC is an important aspect of electrical design, and it's often addressed through a combination of shielding, filtering, and grounding techniques. The specific EMC requirements for a given installation will depend on the type of equipment being used and the electromagnetic environment in which it is operating. In a situation where the motor cable and low-voltage cables were run in separate conduits, this is generally a good practice to minimize potential interference between the power and control circuits. Running power and control cables in the same conduit can sometimes lead to noise being induced into the control circuits, which can cause malfunctions. Separating the cables helps to prevent this from happening. When running cables in conduit, it's important to follow the NEC guidelines for fill capacity. 310.15 and Chapter 9 contain the rules for determining the maximum number of conductors that can be installed in a given size of conduit. Overfilling conduit can damage the cables and make it difficult to pull them. In addition, it can reduce the heat dissipation capacity of the cables, which can lead to overheating. Selecting the correct size and type of conduit is also important. Metal conduit provides better physical protection than non-metallic conduit, and it also provides shielding against electromagnetic interference. However, metal conduit must be properly grounded to be effective. Non-metallic conduit is less expensive and easier to install, but it does not provide the same level of protection. The type of conduit to use will depend on the specific application and the environmental conditions. When passing conduit through a wall, it's important to seal the opening around the conduit to prevent the passage of moisture, dust, and other contaminants. This can be done using a sealant that is specifically designed for this purpose. In addition, it's important to ensure that the conduit is properly supported to prevent it from sagging or pulling away from the wall. The NEC specifies the requirements for supporting conduit in 344.30 for rigid metal conduit, 352.30 for rigid PVC conduit, and 358.30 for electrical metallic tubing or EMT. These sections specify the maximum spacing between supports, which varies depending on the size and type of conduit. When installing electrical equipment, it's important to follow all applicable codes and standards. The NEC is the primary electrical code in the United States, and it provides comprehensive guidelines for the safe installation of electrical systems. However, local jurisdictions may have additional requirements that must be followed. It's always a good idea to check with the local electrical inspector to ensure that your installation complies with all applicable regulations. In addition to the NEC, other standards may apply to specific types of equipment or installations. For example, Underwriters Laboratories or UL standards are often used to evaluate the safety of electrical products. Compliance with UL standards is often required by the NEC and by local jurisdictions. The manufacturer's installation instructions are also an important source of information. These instructions provide specific guidance on how to install the equipment properly and safely. It's important to read and follow these instructions carefully. If you have any questions or concerns about the installation, contact the manufacturer for assistance. When working with electricity, it's important to take all necessary safety precautions. Always disconnect the power before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not qualified to perform electrical work, hire a licensed electrician. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Regarding the statement that the manufacturer recommends the use of shielded cable but does not specify installation or protections, this is not uncommon. Manufacturers often assume that installers will follow best practices and applicable codes. However, it's always a good idea to clarify any ambiguities with the manufacturer if possible. Ask for specific guidance on grounding the shield and any other installation details that are not clear from the documentation. In the context of electrical installations, integral to the equipment generally refers to wiring that is contained within the enclosure of the equipment or is directly connected to the equipment's internal components. This wiring is typically pre-installed by the manufacturer and is considered part of the equipment itself. It is not subject to the same requirements as general-purpose wiring that is installed throughout a building. For example, the wiring inside a motor transformer or control panel would typically be considered integral to the equipment. However, wiring that connects the equipment to the building's electrical system, such as the branch circuit wiring, would not be considered integral to the equipment and would be subject to the general requirements of the NEC. There may be different interpretations from local jurisdictions. Always remember to be professional and respectful.